evaluate 6 trig functions from a triangle. So our 6 trig functions, we have sine of theta, cosine of theta, and tangent. And to get these, we can use our SOHCAHTOA. Now the ones that go with sine, cosine, and tangent are the reciprocal functions. So we want to remember that sine has, its reciprocal function is cosecant of theta. The reciprocal of cosine is secant of theta. That's a C. And then the reciprocal of tangent is cotangent of theta. So, in order to figure these out, we go to our triangle and notice that we're missing theta, which will not happen, so I'll just put that in right here. So according to theta, which is in that spot, we need to know all 3 sides of our triangle. Right now we only have 2 sides, so we can use Pythagorean Theorem. The a squared plus b squared equals c squared. And the one thing we need to remember with Pythagorean Theorem is that your c value has to be the hypotenuse of your triangle. So I know that that c squared, the 9 is going to go there. And then for the other 2, it really doesn't matter. You can put them in either place. So I have a squared plus 5 squared equals 9 squared. So we have 25 and 81. So a squared equals, I think this is 54. Now to undo the, oh, it's 56, of course. I should have known better. To undo the square, we just take the square root. So our side A is the square root of 56. One thing you always want to consider with these is whether or not you can reduce the square root of 56 by dividing by perfect square numbers. And this one actually, 4 does go in, and it goes in 14 times. So this will divide into the square root of 4 times the square root of 14, which then will be 2 times the square root of 14. So I kind of ran out of room a little bit, but now we know this side is 2 root 14. So, getting back to our trig functions, if we're going to do SOHCAHTOA, let's go ahead and label the triangle. In terms of theta, this is the opposite side. Hypotenuse is 9, and the side we just found, the 2 root 14, is the adjacent side. So we just go ahead and set this up. Sine is SO, opposite over hypotenuse. So the opposite side is 5 over the hypotenuse is 9. And since that can't be reduced, that's our sine of theta. Cosecant, all we have to do for the reciprocal functions is flip that. So if I have 5 over 9, I know this one will be 9 over 5. Next we have cosine, which is adjacent over hypotenuse. So our adjacent side is 2 root 14 over 9. To reduce this, you want to look at those outside numbers of the 2 and the 9. So if you had a 2 over 9, they do not reduce. So that's our final answer there. When we get to secant and we flip that, we have 9 over 2 root 14. So this is where we want to make sure that we don't leave a radical in the denominator. We want to rationalize this. So multiply top and bottom by the square root of 14. And get rid of some of that. So we have 9 root 14 over, this 2 is right here. And then square root of 14 times the square root of 14 actually is 14. So in the end, we have 9 root 14 over 28. Whew. All right. Last tangent of theta is opposite over adjacent. So 5 over 2 root 14. Now we have to rationalize this. So multiply top and bottom by root 14. And we have 5 root 14 over, again, this is going to be 2 times 14, so it's that 28. For cotangent, we want to flip our tangent, but one thing we can keep in mind, if you want to save yourself some work, this was our tangent function before we had to rationalize it. So if we flip that, that will give us the correct answer. So 2 root 14 over 5. So in problems like this, just make sure that you find your missing side, be aware of reducing any radicals, and make sure you rationalize all your denominators.